My name is Ralf Müller. By day, I'm a solution architect, and in my spare time, I'm still a geek and love to work in a productive way. So I work a lot with Gradle, Groovy, and Grails, and I'm a contributor to the arc42 open source project and maintainer of the doc toolchain project. And I will tell you now a little bit about both projects. So, what can you expect? I will not go into too many details regarding Gradle and AsciiDoc, but I would like to change your mind on how to work with documentation and give you some more ideas. So, if you have another view on your documentation after this talk, I have a small success. So, about the term docs as code. Who has heard the term before? Hands up. Okay, so it basically just means treat your documentation the same way as you treat your code. And I tried to figure out when the term first showed up, and it was about 2013, it seems. But interestingly, if you work a lot with Grails, what I guess you do, Grails already had the doc command since I only found the documentation for 1.2, but I guess it already was in 1.0. So since 10 years, there's the Grails doc command, and the doc command already treats document as code. It expects some documentation as text in a folder and renders it in a nice way. And the formats you use for writing docs as code are even older. So when you start to treat your documentation same way as you treat your code, it makes sense to write your docs as just plain text and not a binary format like Word. And so you have several format options. One of the older ones is LaTeX. I haven't seen it somewhere outside of universities, but when I studied, it was very popular. Another quite interesting text format is restructured text. I haven't used it myself yet, but it's very popular among the Python community. The renderer for this format is called Sphinx. And there's a huge community of technical writers. They have a website called Read the Docs, where you, as far as I know, just point the website to your Git repository with restructured text, and it renders the documentation on this website. So it's a quite interesting community if you want to learn more about how to write good documentation. Then there's the classic format, Markdown, Textile, and GDoc. The documentation for GDoc says that it's like Textile, but a little bit different. And Markdown is also very popular, and it calls itself a standard, but it always has a problem that it's not as feature-rich as other formats, and this is why it comes in many varieties, because if a tool uses Markdown, then it adds some features, and then you always don't know in which kind of Markdown you're working. And so the last option I present here is AsciiDoc with AsciiDoc as a rendering engine. Am I right if I say that everybody already knows about AsciiDoc? Hands up, who knows about AsciiDoc? Yes. So I guess I can skip quickly over the next 4 slides, because This is just an example of AsciiDoc. What's nice about AsciiDoc is that you can just write your documentation the same way as you write your email. You just write your text down, and the syntax is very easy to memorize. And if you want to convert it to HTML, the Gradle build file is just a one-liner. And it's just that you reference the AsciiDoc plugin, and this plugin assumes that your documentation already lives with the code in the source docs folder of your project. So this already shows that the the docs as code approach is already quite often used with AsciiDoc and Gradle community. Is there someone who uses Maven for his projects? Hands up. Okay, only one. So if you want to use Maven with AsciiDoc, it's a little bit more painful. The basic build script, I think it wouldn't fit on a slide in this font size, but it also has very good support. You start the build and you get a beautiful rendered HTML output. So if you just use AsciiDoc out of the box with your Gradle build, you already get lots of features. You have the distraction-free writing. You don't care about the layout. I mean, if you use Word, everybody knows the problem that your paragraph, your images skip to the next page and so on, and so you fiddle around with a layout. You already have modular documentation, and if you start to version your documentation through Git, you have documentation reviews through pull requests, you have the versioning through Git, and so it's already quite nice to work with. So as you are already all used to AsciiDoc, I think this is the normal way you treat your documentation, the same way as you treat your code. It's quite interesting if you work with a monolith. It makes sense to put your documentation in the same repository as your code. If you work with microservices, it makes sense to move your documentation to another repository and just put some documentation snippets for your microservices and collect them from a central repository. Now, the talk could be over at this point because this is the way most people see the treat docs as code approach. But we still have time. So if you code, you wouldn't be happy if you just would version it through Git and have a simple build to compile it. You do more than that. So for instance, with Spring Boot, you have the Spring Boot starters. With Grails, you have your profiles. And you can do this also with your documentation. You can use templates for your documentation. And today my focus is on solution architecture documentation. And for this, there's a very nice template called arc42, which gives your solution architecture a standard structure. And it also gives you some hints on how to write your documentation. In the German-speaking countries, this is already a standard template, which means that if you use this template, everybody knows in which chapter you will find which information. And the same as you get your Spring Boot starter as Java or as Groovy starter, this template is available in German, English, and even Spanish in several formats, but AsciiDoc is most convenient. And as I already said, it gives your documentation a structure, and it also gives you some hints and some help on how to write the documentation, so how to write the right content the right way. It's interesting to see when you have a template, you are tempted to just fill it out like a form. But the creators of this template say it's more like a wardrobe for your docs. So, like in a wardrobe where you put you have a place for everything, where you put the shoes at the bottom and the hat on top. There you have a place for everything in your documentation, and it's not the goal to just fill out every section. It's more like I have a design decision, let's put it in chapter 9, or a deployment view, let's put it in chapter 7. And if you don't have content for some sections, that's okay. Just leave them empty. And especially with Gradle's projects, I noticed because the architecture is somehow predefined, you can even use pre-canned snippets for some of those sections, or just leave them open because everybody knows that's a Gradle's project. So how does this template look like? This is the AsciiDoc version. It's only one paragraph. And as you can see, there's a section marked with a special role, the arc42 help, which describes which kind of content should be in this section, the motivation, why, which is very important because this helps you to understand the content, the concept behind it, and the form, in which kind of form you should put information in here, whether it's just text, a table, or a diagram. So it's really helpful if you want to document your architecture, and documenting the architecture is very good for a project if you want to help your developers to get a quick start. Now, with AsciiDoc, it's easy for you to write text, and it's also easy to include source code. But with architectural documentation, you do not have so much source code to include, at least if you do an upfront architecture, and the source code isn't there yet. So you soon need diagrams. And who knows about plant UML? Okay, I would say half of the audience. Plant UML is a great tool which lets you describe your diagrams as text and then renders them in a quite nice way. But it also takes its freedom to lay out your diagram. So this way we can also handle our diagrams as text and use the same mechanisms for version control. We have a div on the diagrams. That's quite nice. And I once gave it a try with a more complex diagram. This was a diagram someone gave me of an open source project which he wanted to have as plant UML. And I somehow succeeded to turn it into a text-based diagram. It describes the same content, but I also noticed that when you turn an already existing diagram into plant UML, that works fine, but you don't want to model such a complex diagram just in text, because you have to give plant UML many hints on how to render it in a nice way. You have to tell them, hey, this arrow, please do it downwards. And so behind this QR code, there's the source code of this diagram if you're interested in this. So plant UML is quite nice if you don't have to model your diagram, if you only have a small diagram, or if you want to generate diagrams from, for instance, your domain model. But where plant UML really excels is with sequence diagrams. So a sequence diagram in plant UML really looks as, it's just the data you have to write down, and it renders in a very nice way. And if you have to change something in your sequence diagram, you just change the text and it still renders in a nice way. All the UML tools I know with which I've tried to create sequence diagrams, it's a pain if you have to change it somehow. And so that's why I only use plant UML for sequence diagrams and no other tool anymore. By the way, when it comes to architectural diagrams, I struggled a long time on how to create my component diagram. If you have the same problem, you should take a look at the C4 model by Simon Brown, because he has a nice way to approach the component diagrams by splitting them up into a context, container, component, and class diagram. That really helps me a lot when creating such diagrams. Okay, so plant UML is nice, but I need some other tool for more complex diagrams. And by the way, plant UML is quite good supported by AsciiDoc. If you want to render HTML with plant UML, you just have to reference a plugin. If you want to render PDF, then you have to set up a little bit more so that your diagrams render in HTML and in PDF. But more about this later. So when you want to render more complex diagrams and you have some UML modeling tool, then you always have the problem that it's hard to keep the images up to date. When you have, for instance, 10 diagrams and you change the name of one component, it's likely that 8 of those 10 diagrams change, and then you have to somehow save as all those diagrams and maybe even re-reference them from your documentation. And also what I really like with UML modeling tools is that I can write nodes behind those elements, which help me to navigate through the diagrams. And those nodes are also lost when you export those images. So some people therefore do not write the nodes behind those elements, but add nodes to the diagram, but this makes the diagram not more readable. So the approach I use for this problem, and who uses the Sparks Enterprise Architect? Hands up. Okay, only one. That's what I meant when I said I want to present ideas. So not everybody uses the same tooling, and in this case I used the Sparks Enterprise Architect, and this is a UML diagram within this tool, and you see the highlighted actor and the comment behind it. And when you work with code, you automate a lot, and you can do it the same when you work with documentation. So you can automate the task of updating your images. In this case, I added a small tag here displayed in green, which just gives my build script a hint on where to append this information. So in this case, I state that this should be written to the stakeholder AsciiDoc file, and all nodes with this tag will be appended to this file. And as a result, I created a Gradle build task which exports all those images, exports all those nodes, and then I can include this information from within my AsciiDoc. And that's also the reason why I really like Gradle for building documentation, because in Gradle I can easily create new build scripts, and these are really scripts because I can use Groovy to script everything I like. And in this case, it's a Windows-based tool, so I used Visual Basic. So from within Gradle, I have a Groovy script which starts a streaming execute, which then executes Visual Basic, and while it works, it already displays the output of the Visual Basic file, and then everything is exported. There are ways to automate Windows tools through COM bridges, but these require DLL to be installed, and so you have an additional dependency. And if you already have a Windows tool, then you have Visual Basic available, and so it works nice. But as I thought, it's an idea, and if you have a different tool, you can also easily automate it. And for instance, we also have a script for Visio. If you use Visio for your diagrams, go ahead. And as a result, this time rendered as PDF, you have within your documentation your UML diagram, and underneath, in a nicely rendered table, all the information you have behind your elements. So, but now we treat our docs as code. We can work with diagrams, but not everybody likes the documentation rendered as HTML. If you work in a corporate environment, then you might need to create Word files or PDF so that they can be sent around, not only a link to be sent around, and maybe also to be archived. And also, if you have a huge architectural documentation, you have different stakeholders who don't want to read the whole documentation. And that's very nice with AsciiDoc, because you can just create a master document which includes all sub-documents. You can create for different stakeholders different master documents, so that you can, for instance, create one document for your business people, one for your developers, and one for your security people. It's very nice. And it also helps you, for instance, if you like this approach, to use arc42 as a template, but the company you work for has its own template. Then you can create two master documents and create both templates out of it. But back to the output. If you want to create Word documents, it's also easily possible, not directly through AsciiDoc, but you can use a tool like Pandoc, which is like the Swiss Army knife for document conversion. It's not very good in handling styles for Word, but there's a small trick. If you create a master template for your Word document with all the styles, and from within Word reference your generated document, then it renders with those styles from the master document, so it's easily to change the styles, and then you again can use a Visual Basic script to save this master document with a reference document as just one document. When it comes to, that's an example of this rendered Word document. When it comes to PDF, the PDF plugin for AsciiDoc is quite nice. It's, as far as I know, still in alpha, but for that kind of documentation I write, I don't find too many issues, so it's quite usable already. And when you work with those page-oriented documents, just a small hint, AsciiDoc supports page breaks. Normally you don't use them because you just render single-page HTML files. But if you put some, at least over the main headlines, those page breaks, those 4 less than signs, that adds to the readability. Okay, so architectural documentation has just plain text, has diagrams, but also has lots of tables. And managing tables in AsciiDoc is quite nice because you can split your columns over the rows, and it's really helpful. But and it also renders nice. But sometimes your tables get more complex, and sometimes those tables are supplied not by technical people, but by your business people. For instance, if you have some non-functional requirements in a tabular format, maybe in Excel, then it's hard to manually convert it to AsciiDoc, and then when it's in AsciiDoc, the business people can't manage it. So wouldn't it be nice to edit your AsciiDoc table with Excel? If you use Apache POI and another Gradle build task, it's easily possible. So you can create a build task which just looks for Excel files in your source docs directory, converts them all to AsciiDoc snippets, and then you include those snippets, and you get very good results with this. And this is just an example. I once played around with it. If you have more complex tables, if you have call spans and cell spans, then I think nobody maintains those tables in AsciiDoc. But with such a build step, it's quite possible. Okay, then working together. Docs as code. When you work with code, you are used to pull requests because you work together with technical people. If you write your documentation together with other technical people, that's also a great option, pull requests. But when you work together with other business people, then they don't want to go into your Git repository and do pull requests. And so often people tell you, but all the other docs are in Confluence, and what about your documentation? Can't you put it into Confluence? And Confluence is also a tool which helps you to get feedback because of the page comments. And Confluence pages are stored as XHTML. So that's quite nice because AsciiDoc renders to HTML to XHTML. And Confluence also provides a REST API. So I think you already see a pattern here. You can build a Gradle build step for publishing your AsciiDoc to Confluence. And it works quite nice. It makes sense in this case when you have your HTML, rendered HTML, it's one large HTML file, and large pages in Confluence are not so nice. You can't use the page comment feature in an efficient way if you have just one page. So it makes sense to split up your document, at least for the 2 main heading levels, into sub-documents so that you can get smaller pages. And when doing so, you can use the comment feature in Confluence. You create read-only pages, so people are forced to use the comment feature, and you get directly feedback on your document, even from non technical people who are not willing to send you a pull request. By the way, you can also use inline comments in Confluence. If you mark text and hover over the text again with your mouse cursor, small pop-up shows up. If you click on this, you can create an inline comment, the same as you do with Word in a review mode. Who already knew this feature? Hands up. Okay, only 2. It's always surprising if you work for years with a tool and then discover such a feature because you never gave it a try. Okay, now you now create a complex documentation, and you soon notice, because everything is built automatically and you reference images or sub-documents just by name, that you get quality problems, that you have broken links, broken images. But again, treat docs as code. How would you solve such a problem with your code? You would write automated tests. And in this case, you don't have to write your own build step, because there's already a plugin available, the HTML sanity check, which checks for broken cross-references, missing image files, and so on. And it creates a report which looks like the other reports you create for your automated tests. And it's quite helpful. So this at least finds all those obvious problems with your documentation, where you just have to fix a broken link. But you can even go one step further, and that's what I learned from the community of technical writers. With your code, you use style checkers, and you can also apply style checkers to your documentation, to your natural language text. They are all also called linters, and this is an example from the webpage hemingwayapp.com. These libraries analyze your text for readability, for too long, too complex sentences, but also for some fill words which don't have a meaning, which just make your documentation more complex. And so you can also use those linters to check for the quality, for the readability of your documentation. And yeah, that's the next step in treating your documentation the same way as your code. Okay. Now, when you create architecture, you also often have to present your architecture to other people. We've seen it here in the conference often that there was a presentation, for instance, Open Dolphin showed the architecture behind the system. And so you create, as an architect, lots of presentations, and you give the talk, and later on you send around the slides without the spoken word. And so lots of meaning gets lost. But you can also use the docs as code approach to solve this problem. Because even your presentations, you can automate the export of the slides and thus include the slides in your documentation, add documentation to the images, and you can even, if you want to maintain all of this in one place, write AsciiDoc, the additional documentation in the speaker notes of your presentation, export it all together, and then render it as HTML Word or PDF, and send this around instead of just your slides. So, if you think that creating all those build steps is quite complicated, then you are right. Just using AsciiDoc is simple, but to use several sources for your documentation and to render several different kind of outputs is quite more complex. And that's why I created the Doc Toolchain project, which tries to create a build which has already all those build steps included. And it's organized in small script files, script plugins for Gradle. And as you can see, there are more build steps than I just told you about. For instance, you can, if you want to work with living documentation and also track the issues which exist with your documentation the same way you track issues with your code. You can, for instance, export all those issues from Jira or another bug tracker and include it in your documentation. Or sometimes you need a changelog in your documentation. Now, if you version it through Git, you can just export the changelog from your Git repository. Makes sense, I think. And also with the output, you can use AsciiDoc to export slides through Reveal.js and also EPUB, which is sometimes quite nice if you have larger documentation. Okay, so I finished a little bit sooner than I thought. Thanks for your attention. Here are some more links on the last slide. The QR code will bring you to the slide deck in just a moment when I published it. Are there any questions about this approach? Yes?
I have several questions. Thanks for the talk. Regarding the page breaks for rendering PDFs, if you want to output to HTML and also to PDF, how will those page breaks move in the HTML page?
You won't see them in the HTML, but if, as far as I know, if you print the HTML, they will be visible. They will be real page breaks.
Okay. Another question regarding the Excel to AsciiDoc cable. Do you have any example available online about that?
Yes, there's this build script, and there's an example file with those two examples, this one address table and this Tetris table. And I have to say it works quite nice. Yeah. It uses a background color. It tries to make use of all the attributes you have available in AsciiDoc. So not everything which is possible in Excel is possible in AsciiDoc, but if you know about the AsciiDoc features, you know which features you can use in Excel.
And the last question is regarding the Confluence API documentation upload. As well, you have an example available, and also you mentioned that instead of, if you are, for example, documenting an API, instead of creating a single page with all the API documentation in Confluence, to create multiple pages. How will it look like in AsciiDoc? You will have like multiple AsciiDoc files, one per endpoint, or will it use the input feature in AsciiDoc?
So when it comes to API documentation, I don't have too much experience about this because I mainly work with architectural documentation, and in this case we split the pages by the two main heading level.
So each page is a single AsciiDoc file?
No, you have several AsciiDoc files which render as one large HTML file, and this HTML file is split up by heading level. And what's also quite nice with the Confluence approach, with those smaller pages, if you set up the notifications on those pages, then the script does a good job in checking whether the page changed from one publishing to the next one, because Confluence has the API has a problem. It doesn't recognize if you just publish the same page again. It will create a new version whether the page has changed or not, and will send notifications. So we store a hash within the page to first check whether the page really has changed, and this is also a very nice feature. Yes.
So regarding Confluence, I was wondering, I mean, the pages are not editable because the content itself is not the Confluence wiki markup. It's HTML. It's just HTML inside a macro or something. And it cannot be editable using the Confluence editor.
It is editable. That's not a problem. Confluence takes the HTML, rewrites it a little bit, but after this, it's a normal Confluence page. But you have the problem that you will overwrite the changes with the next publish. And that's also the problem with those inline comments. Those will get lost if you just publish your page another time over this. So it makes sense to just make those pages read-only. And in one project, we used just a small warning on top of the page that this is auto-generated, please do not edit. And if this warning is removed, then the script knows that this is manually edited and doesn't publish its content over it.
Also exists a plugin for upload files to top, so you don't need to know the API of Confluence because there is a plugin, an extension of AsciiDoc that do it.
Yes.
But not so good.
So
It's so.
yes, there are some extensions, and the script we have in Doc Toolchain, I'm a little bit proud of it because it really works nice. It, for instance, also renders the admonitions the right way, and for the arc42 template, those help sections are rendered as hidden sections so that you first have to open them to see them.
How does Doc Toolchain works exactly? It's like it's a Gradle plugin. You said it's a script, but
It's not yet a real Gradle plugin which you reference. It's itself a Gradle project, and it's organized in script files. So you have a folder where all those different tasks are in. And so you can, for instance, if you want to use it in your next Grails project, you could download it and just move those scripts which you would like to use to your own build file. The goal is to make it even easier, but the first goal was to have this build script, and in this case you can start with a architecture solution documentation with this build script and then add code to it. But one of the contributors also changed it a little bit, that he added a bin folder with a shell script so that you can use Doc Toolchain like an external tool and just use it. Just render it with your documentation with a command from the command line. So it comes in several flavors.
Thanks for the talk. Do you think there are any real drawbacks to using LaTeX, or is it simply just not hip enough anymore for the communities?
I haven't used LaTeX a lot. And yes, I think it's not hip enough. I don't know whether it renders to HTML. I know it renders to PostScript. So yeah, if you need some features of LaTeX, formulas or something like this, go ahead. But in this case, my focus was on AsciiDoc. Yeah?
Again, on this to export to Confluence. I was wondering if it works with AsciiDoc code blocks. So if you have a code block, with callouts, and you want to export that, because obviously we are talking about technical implementation.
Yes.
Normally you have the syntax.
As far as I know, it works. I don't use this feature in my daily work, but someone else, I think, fixed this feature, because those extra features are just in the HTML of Confluence macro tags, and so you just have to convert such a code block into a macro block. And this works quite nice.
So right now it's fine.
Yeah, okay. So thanks for your attention.